Okay, dear student, let me first talk and then tell me about my eval. Okay, today we are going to talk on, you will learn about method of partial fraction. So far you have done, the first topic was on basic integration formulas, how to use substitution, and then integration by parts. In the last lecture, you learned how to integrate product of two functions. Right? For that, you applied the formula for integration by parts. Today you will learn about method of partial fractions, and in this section we will learn how to integrate rational functions by reducing them to a sum of simpler fractions. So what do you mean by rational functions? Yes. And what is P by Q? Polynomial. And is there any conditions on the polynomial? Q of x is not equal to 0, that is there should be no Q of x cannot be equal to 0 at any x. Identically 0 na, lekin at any x 0. So what is a polynomial? Bas. Combination of a constant and a variable. So it's a polynomial. Yes, degree. How do you relate the degree or the power? This is not a polynomial. So rational function is basically the fraction of polynomials in which q of x is not equal to 0 for any x, for all x, for all x. It should be not equal to 0. Then it does not exist any point where q of x is equal to 0. So this is my rational function. And what about the polynomial? A function in which the power or exponent of the variable is positive integer. It can be 0 as well. It can be 0. X power 0, 1. 1 is also a constant. 2 is a constant. 3 is a constant. So the polynomial is a function in which the power of or the exponent of a variable is non-negative. Non-negative integer. Okay, and for that such type of fraction is called a rational function. And reducing them to a simpler fraction, what we are going to do? We will write rational functions as a sum of simpler fractions, and those simpler fractions are called partial fractions. Right? Okay. We show how to integrate any rational function, that is a ratio of polynomials, by expressing it as a sum of simpler fractions, that is partial fractions. So we will reduce, if we have to integrate rational function, we will first reduce them or to partial fractions, or we will write them as a sum of simpler fraction or a sum of partial fractions, and then we will integrate. So far we have been doing it, that is, we know how to add two fractions. This is plus and not equal to sign. How to add these two fractions by taking LCM, and then we will get this answer. But now we have to do the reverse process. We are given this rational function, that is this one. We have to integrate it, and if we have to integrate such rational function in which both the functions in the numerator and in the denominator are polynomials, then we will do this reverse process. That is, write it as a sum of fractions which are simpler than this. And this process is called method of partial fractions. So this is only done for the purpose of integration, right? So that's our task in today's lecture. So what I'm going to do, I will write it this, I have to integrate this function. I will do the reverse process, write it as a sum of simpler fractions or partial fractions, and then apply the integration. Very simple integration where C is any constant. So the definition of polynomial. Now I have two type of fractions or two type of rational functions. One is proper and one is improper. How do you differentiate both? If the degree of the polynomial in the numerator is greater than equal to the degree of the polynomial in the denominator, then that fraction or function is improper, and otherwise it is a proper. If it's equal, we will also call this an, if the degrees are equal, we will call it an improper, right? So if f is improper, that is the degree of p is greater than equal to degree of the polynomial q, then we must take the preliminary step of dividing q into p, that is long division. So whenever you are given integration of a rational function, the first step is to check whether the rational function is an improper or a proper fraction. The first preliminary step, the first step is to check the proper or improper. If it is improper fraction, you will do the long division, right? Long division, correct? And then write it in this way. That is, if my fraction or rational function is improper, I will do the long division, and this is quotient. All of you know how to do long division. This is my remainder, and this q of x is the same one. This is divisor. Okay. This is the result of long division. After that, now I will get a proper fraction. For example, take the example of this function, this rational function. I have this rational function x cube plus x over x minus 1. I have to integrate it. I have a rational function. The degree of the polynomial in the numerator is 3 and the degree of the polynomial in the denominator is 1. So I have to do the long division. And after long division, I will get this. Now I will apply the integration. Since integration is a linear transformation, so I can take the terms, I can do the term-wise integration. Integration of the sum of the functions is equal to sum of the integration of the function. That property helped me to do this process. Now integration of x square is x cube over 3, integration of x is x square over 2, integration of 2 is 2x, and integration of 2 over x minus 1 is 2 natural log of x minus 1. Okay. We all know how to integrate this. Right? So this is your first step. The next step is to factor the denominator q of x, the polynomial in my denominator. I have to factorize it as far as possible. This as far as possible is very important. If you can take the constant common, you have to take that constant common. Right? And how to factor? All of the methods you have learned in your previous classes. So it can be shown that any polynomial q can be factored as a product of the linear factor. This is my linear factor, a and small a and b are constant. Irreducible quadratic factor. So I have to factorize this q, the polynomial q that is in the polynomial in the rational function of the denominator in the rational function into linear and irreducible quadratic factors. And what is this irreducible? What do you mean by irreducible? Which cannot be factorized further. And how do you know that this quadratic factor, this quadratic function is irreducible, cannot be factorized further? This is discriminant. B square minus 4ac. That is, if I have to find the roots of a quadratic equation or a quadratic function, b square minus 4ac over 2a. Then the nature of the roots depend on this. If it is equal to 0, if I have a polynomial of degree 2 and I have to determine its, then there are two roots of that. If this b square minus 4ac is equal to 0, then the roots, I will get a single root, that is a repeated one. Ye 0 again. If b square minus 4ac is greater than 0, I will get two distinct roots. And if this b square minus 4ac is less than 0, no roots. That is cannot be factorized further. It is irreducible. So this discriminant will tell me whether the quadratic factor can be further factorized or not, irreducible or not. So if you get b square minus 4ac less than 0, because over here then you will get a complex roots. But we are dealing with the real one, so we will eliminate this case. We will not factorize. But we can get, but in the real case we can get fractions as well. Real roots. So we can get integers as well as fractions in your roots. Okay, for instance, we have to factorize this x power 4 minus 16. You know how to factorize it? X square minus 4 into x square plus 4, and x square minus 4 can be further factored to this x minus 2 into x plus 2. And this is my irreducible quadratic factor. If I check b square minus 4ac, it is less than 0. So this is the factorization of the polynomial q of x. So the second step is to factorize your polynomial. Now the third step is to express the proper rational function, that is this one, after your long division, if it is possible, as a sum of partial fractions of this form. That is, for the linear factor, you will write constant. You will write it at sum of this. And if you have quadratic factors with any power, you will write it as ax plus b, where this a and b both need to be determined. Both are unknowns. So you write your fraction as a sum of, after factorizing, you have to write it as a sum of the fractions. A theorem in algebra guarantees that it is always possible to do this. That is, you can factorize it into linear and irreducible quadratic factors. So there are 4 cases. The denominator q of x is the product. Let me write all the 4 cases of the factorization of q of x. The 4 cases of the factorization of the polynomial q of x. The first case is if I will get distinct linear factors. Case 2 is repeated linear factors. Case 3 is distinct irreducible quadratic factors. And case 4 is repeated irreducible quadratic factors. So I have only 4 cases. Any of this. My question is of any of this case or the combination of these cases. Right? So in the third step, when I have to factorize my polynomial q of x, then after that I have to write it as a sum of partial fractions. And for that I have 4 cases. Distinct linear factors, repeated linear factors, distinct irreducible quadratic factors, and repeated irreducible quadratic factors. Let's see what is my case 1. Case 1 is the distinct linear factors. That is, I have this case. I am writing it as in a general way. Obviously, I will have some values for a1, b1, a2, b2, and b3. So I have to write for distinct linear factors. I have to write some unknown a1 for the first linear factor plus some unknown for the second linear factor up to ak for the kth linear factor, if I have k linear factors, and then I have to determine these k constants, these k unknowns, constants. These are all constants. They cannot take any variable, not equal to any variable. So now this is my fourth step. Let's see an example. Example 2. For the first case, first of all, the preliminary step is to check whether the function is proper or improper. Is it a proper? Yes, it's a proper fraction. No need to do the long division. So we will, now the second step is to factorize it. So do the factorization, factorize this q of x. Okay, do the factorization, 2x cube plus 3x square minus 2x. Any of the method you know. You can do synthetic division for higher power. चलिए भी आप यूज कर सकते हैं सिंथेटिक डिवीजन, कैलकुलेटर भी आप फैक्टर्स आप After factorizing it, write it as a sum of simpler fractions as well. How many factors you get? 3. X into 2x minus 1 into x plus 2. And after that, write it as a sum of the partial fraction. Now your task is to determine these three unknowns, A, B, and C. How will you get these three unknowns? Yes? But first see that I have one equation and I have three unknowns. I need to uniquely determine these three unknowns, I need three equations and to determine these three unknowns. And if I have less number of equations than the unknowns, if number of equation is less than the number of unknowns, what would be the situation? What would be the values of A, B, and C then? Let's say A and B both are expressed in terms of C, or B is expressed in B and C are expressed in terms of A. That is, one variable is free. You are free to choose. You can take any value of that variable, and the other two are dependent. Other two unknowns are dependent on that free variable. Right? This is the case when the number of equations is less than the number of unknowns. ठीक है, ये चीज समझ लें, ये बाकी काम बाद में करिएगा. ये कैलकुलेशन से ज़्यादा इम्पोर्टेंट पीछे कॉन्सेप्ट होता है. कैलकुलेशन तो हम किसी ना किसी तरीके से कर लेते हैं, लेकिन कभी ऐसी कैलकुलेशन आ गई जिसमें आपकी इक्वेशन या वो उसमें कॉन्फ्लिक्ट आ गया तो फिर क्या करेंगे? बैठे रहेंगे फिर आप कहेंगे ये सारा हमारे पास अनसीन है. Concept is more important than this calculation. Calculation is all based on the concept. So if you have less number of equations than unknown, then some variables are free, arbitrary. And if you have greater number of equations than unknowns, if the number of equations is greater than the number of unknowns, then तीन ये situation हो सकती है. The number of equations is equal to number of unknowns. You can determine the values of the unknowns uniquely. Each is a unique value. If the number of equation is less than the number of unknowns, then there are some variables that are free, arbitrary. There is no constraint on that variable. If you have two equations and three variables, one variable is. If you have three equations and 5 variables, you have two free variables. जितनी ज़्यादा है उस हिसाब से. And if you have greater number of equations, तो फिर you can choose any of the three equations and you determine. If you have 4 equations and 3 unknowns, how will you determine? And that would be the solution of all 4 equations. Then all the 3 unknowns must satisfy the 4th equation. It must satisfy the 4th equation or the equation you have not used for the solving or finding the unknown. Otherwise, if the values do not satisfy the 4th equation, it means these 3 values are not the solution of the whole system, all the 4 equations. It would be the solution of only those 3 equations. So if the number of equations is greater than, yes.
मैम ये इक्वेशंस नजर नहीं आ रही है. 4th इक्वेशन, 3rd इक्वेशन, ये कौन सी इक्वेशन है?
ये कोई इक्वेशन नहीं, ये तो सिर्फ मैं भी आपको लीनियर अलजेब्रा करवाती थी. फिर मैं इक्वेशन तक पहुंची नहीं, मैं तो सिर्फ ये बता रही थी कि आपको अननोन्स, यू नीड टू डिटरमिन दोज अननोन्स एंड यू हैव नंबर ऑफ इक्वेशंस, उनका रिलेशनशिप बता रही थी. क्योंकि लीनियर किया नहीं है तो वो सिचुएशन में बता रही थी. ठीक है, अभी मैं कुछ नहीं लिख रही, जो भी लिखूंगी वो आपको नजर आएगा यहाँ पे. So if you have 5 equations and 3 unknowns, then that system must be compatible. कंपैटिबिलिटी होगी. कंपैटिबिलिटी का मतलब यही है कि जिन इक्वेशन से आप डिटरमिन कर रहे हैं उसमें कोई कॉन्ट्राडिक्शन ना आए, वो सारी इक्वेशंस को सेटिस्फाई करे. और जब हम यहाँ से इक्वेशन डिटरमिन करते हैं तो इक्वेशन को कंपैटिबल होनी चाहिए. अगर नहीं आ रही कंपैटिबिलिटी, इसका मतलब है कि यू हैव डन समथिंग रॉन्ग इन योर कैलकुलेशंस, आपने कंपैरिजन ठीक नहीं किया. Now after writing it as a sum of the fractions, you have to determine these 3 constants A, B, C. For this you need at least 3 equations. You need 3 equations to determine these values uniquely. For this what you do, you multiply both sides with this Q of X. You multiply both sides with QX, you do the same process on both sides, so the equation remains the same. So after multiplying this, x square plus 2x minus 1 is equal to this. Now our task is to determine the unknowns A, B and C so that we can integrate it. This. Now I have a polynomial of degree 2 on my left hand side and a polynomial of degree what? Let me check. Over here I will get 2, maximum 2. X multiplied by this polynomial, and this is again a degree. So I have a polynomial of degree 2 on the right hand side. Now the two polynomials are equal. This polynomial is equal to a second degree polynomial on my right hand side. They can be equal if and only if. What is the condition? Stop writing, all of you first. Stop doing this. The two polynomials of same degree are equal if and only if their corresponding coefficients are equal. The coefficient of x square is equal to the coefficient of x square of both the polynomials. The coefficients of x of both the polynomials is equal and the constants are equal. Means the coefficient of x square over here is 1 and over here it is. I have to multiply this with this. I have to multiply this and this, and I will get it. Now I have sorted the terms. X square के साथ ये चीज आ रही है, ये सब चीजें. Now I will compare because both the polynomials are equal. It means their corresponding coefficients are equal. The coefficients of x square. Over here I have 1, and on the right hand side the coefficient is 2a plus b plus 2c. This is coefficient of x square. What about coefficient of x? On the left hand side I have 2. On the right hand side I have 3a plus 2b minus c. And for about the constants, on the left hand side I have minus 1. On the right hand side I have minus 2a. Now I have 3 equations and 3 unknowns. I have to solve it by using your calculator as well. Solve it and then put these values over here. And then integrate. Now the integration is very simple. Integration of 1 over x is natural log of x. Integration of 1 over 2x minus 1 is 1 over 2 ln of 2x minus 1. Integration of 1 over x plus 2 is ln of x plus 2 plus any constant k over here. I'm using k for the constant because I have used capital C for this unknown. So to avoid this conflict, I'm writing it as k. So there is a shortcut method as well. All of you know about that method. And this shortcut method is used only for the linear factors, not for the repeated one, distinct linear factors. You can use the combination of the shortcut method and the general method. The general method is this one that I have explained, that comparison method, comparing the coefficients. For the quadratic factor, you have to definitely move to the this general method, but for the linear factor, you can at least uh, determine those unknowns, a few unknowns, before comparing the coefficients. So the shortcut method is, if I put x is equal to 0 in this equation, not in this equation, actually in this equation or this one, I can determine the value of a. If I put 2x minus 1 equal to 0, I can determine the value of b. And if I put x plus 2 equal to 0, I can determine the value of c, but not over here in this equation. In this or this. Okay, if I put x is equal to 0, minus 1 here, and over here I will get minus 2a, and this is 0, this is 0. So this implies that a is equal to 1 over 2. If I put 2x minus 1 equal to 0, this implies that x is equal to 1 over 2. Put 1 over 2 over here, 1 over 2 here, and then solve it for b. Because this gets 0, this gets 0. I'm left with only this one. I can determine the value of b from this equation. And then you have to put x plus 2 equal to 0. That is, x is equal to minus 2. Minus 2 over here. This is 0. This is 0. And you will determine the value of c. Okay, this is your shortcut method. You can use this as well. Got it? Any question related to this?
मैम ये शॉर्टकट मेथड कब यूज करना है और जो दूसरा वाला है वो कब यूज करना है?
जब आपके पास लीनियर फैक्टर्स होंगे तो आप आराम से शॉर्टकट मेथड यूज कर सकते हैं. सिर्फ लीनियर फैक्टर्स होंगे केस 1 के लिए, डिस्टिंक्ट लीनियर फैक्टर. इफ यू हैव रिपीटेड तो फिर आपको कंपैरिजन यूज करना होगा. दोनों मिक्स करके भी यूज कर सकते हैं कि पहले कुछ कोएफिशिएंट्स आप डिटरमिन कर लें शॉर्टकट मेथड से जिसमें सिर्फ लीनियर आ रहा है, पावर 1 आ रही है, और फिर जो रिपीटेड है वो फिर आपको डिटरमिन करने होंगे कंपैरिजन से. क्वाड्रेटिक तो होते ही उससे डिटरमिन है, लेकिन अगर मिक्सचर आ रहा है तो फिर हम उसको करेंगे. ये भी हम देखेंगे जब हम कंप्लीटली क्वेश्चन सॉल्व करेंगे. देखेंगे अभी आपको करना है, ये वही एक्सप्लेनेशन है. यू हैव टू डू दिस एग्जांपल नंबर 3. ओके, सॉल्व इट. इंटीग्रेशन ऑफ dx ओवर x स्क्वायर माइनस a स्क्वायर वे स्मॉल a इज एनी कांस्टेंट व्हिच इज नॉट इक्वल टू 0. ओके, थोड़ा सा हुआ है सामने, लेकिन चलें खुद करते हैं. डू ऑल द प्रोसेस. यस, जब आप पार्शियल फ्रैक्शन करेंगे तब तो वो सिचुएशन नहीं होगी कि आपने उनको करेक्टली डिटरमिन किया है और आपके पास आ रही हैं तो वो सोल्यूशन हो सकता है कि आपने सोल्यूशन गलत किया हो, वो कंपैटिबल भी होनी चाहिए. समटाइम्स ऐसा होता है कि आपके पास ऐसे सिस्टम आ जाते हैं, ये मैं इन जनरल बात कर रही थी कि आपके पास जो भी कंपैटिबल नहीं होती उसका सोल्यूशन, उस सिस्टम का सोल्यूशन ये आप. लेकिन इस केस में मैं ये बताती कि अगर इक्वेशन ज़्यादा है, अननोन कम है और आपकी कोई ऐसी सिचुएशन आगे उसका मतलब आपकी कैलकुलेशन नहीं होती, तो यहाँ पे कंपैटिबिलिटी मैटर है. आप एक सिंगल इक्वेशन से लेके आए ना तो वो कंपैटिबल होगी. जैसे आपके 5 इक्वेशन जैसे वो लिखने में मसला होता है, तो वो तरीका कवर डिक्शन नहीं. Now you can use the shortcut method in this question to determine the unknowns capital A and capital B. And remember that you have a constant small a in your question, means your constant unknowns will be expressed in terms of small a, can express in terms of small a. So don't forget about the small a. So these are the values of the unknowns. The coefficient of 1 over x minus a is 1 over 2a, and the unknown for the factor x plus a is minus 1 over 2a, right? And then do the integration process. This integration is very simple. Now you can apply the property of logarithm and write it in this. Okay. Let's move to the next case, in which q of x is a product of linear factors, some of which are repeated. For that, you have to write, if the factor is repeating r times, you have to write it r times with r unknown coefficient. First for the linear one, then an unknown for the second degree, and up to the rth degree. For example, if I have 1 over x minus 1 cube, q of x contains repeated linear factors, that is the factor x minus 1 is repeating 3 times. So I will write it as a over x minus 1 plus another constant b over x minus 1 whole square plus c over x minus 1 whole cube. I will do it until I will get this power. Now I have to determine these 3 ABC by comparison method. I can determine A only by the shortcut method, by putting x is equal to 1. Okay. So this is the case for second case. That is, if I have this for illustration, x cube minus x